Alright, dear children, welcome back to the class. Today we'll discuss some of the important questions on electricity. Already you have got two videos and this is the part 3. I have divided this chapter into 3 parts, okay? You must be seeing this first video and second video, so you see them and you come to this third video so that you get complete feel of this. Alright, so anyway, let's start this video. So the entire 10th standard syllabus, so whatever this 10th standard syllabus is there, the entire 10th standard physics and mathematics syllabus, so all these videos, all these important question, entire physics and mathematics, so whatever syllabus is there, so all those important questions will be posted and you can visit them in the playlist. So whatever playlist we have formed, so in those playlists all those questions will be there. All right, so then let's get on to the first question. So what is this? The first question is quite simple. So the question is like this: what is heating effect of electric current? Okay, they're asking you what is heating effect of electric current. Okay, from the question itself you can say this answer: heating effect, right? Heating effect means what? Heating effect of electric current. So whenever we pass current in a device, it gets heated. This is only known as heating effect. For example, I have got one electric device here. All right, so one electric device is there. Now for this, if you're providing current, if you're supplying current, so definitely it will do work, so there is no doubt in that. But in the process of doing this work, it gets heated, no? All right, so these mobile phones get heated, fans get heated, electric motors get heated. So this phenomenon itself is known as heating effect of electric current. When we pass current through a device, current through an electric device, they get heated. This is known as heating effect of electric current. This is known as heating effect of electric current. There is something called magnetic effect of electric current also, that we'll see it in a different chapter. All right, so the first question was quite simple. Now second question is like this. So what is the second question? Define Joule's law of heating. Very important question. Very often this question is being asked. Define Joule's law of heating. All right, so what is this Joule's law of heating? Now for this you have to draw one circuit. You have to draw one resistor. Resistor means this is resistance of a device only, and in this you have to pass some current. This current will come from some source only. For example, here is the battery. Now in this current this current I is passed in resistance R for time t. Okay, so I am going to write this as when current I is passed in a device, of resistance R for time t, it gets heated. It gets heated. Once again I am repeating. What is this? When current I, this is very important, when current I is passed in a device of electric resistance R, this is also very important, for time t, okay, it gets heated. Then Joule's law of heating says that heat means H, that heat produced is, first one is directly proportional. It is directly proportional to square of, current. It is directly proportional to square of current passing through the device. All right, so that is like H is directly proportional to I square. So this is the first one. And second one is like this. This is directly proportional to the resistance directly proportional to the resistance of the device. Resistance of the device, that is like H is directly proportional to R. And third one is also very important. Third one is like whatever heat is produced, that is directly proportional to the time period, for which current is passed, all right. So this is going to be H is directly proportional to T. Now we have three things, no? I mean from 1, 2 and 3. So I am going to combine them. Then I am going to write H is directly proportional to I square RT. All right. In this proportionality constant becomes K, and K into I square RT. But in this SI system, the value of this K is equal to 1. Why? Because this heat is there, no? So whatever heat is there, it is dependent on current, resistance and time only. There is no other factor which decides this heat. So that's why it becomes 1. So therefore H is equal to I square RT. So this is the complete answer. This is how you are supposed to write when the question on Joule's law of heating is asked. Alright, then you will get complete marks for this. Alright then, moving forward, let us look at the third question. Third question is like this: if the below shown circuit, I mean they have given one circuit here. I mean if the below shown circuit is turned on for 1 minute, find heat produced in 2 ohm. Okay, so here is a circuit. We have got one resistance here, and here there are 2 resistors. All right, they are connected in parallel like this with this one more resistance, and here is the battery. All right, and here there is a key also. Okay, and this is like plus or minus 12 volt, and here it is 2 ohm, and here it is 3 ohm, and it is 6 ohm. What is the question here? If the below shown circuit is turned on for 1 minute, that means the time period is given. How much is the time period? Look at this, time period is equal to 1 minute, and SI unit is like second. That's why 1 minute means 60 seconds. Now if this is turned on for how many minutes? 1 minute. They are asking find heat produced in 2 ohm. In this resistance 2 ohm, how much heat is produced? Now you know the formula for heat produced, no? Alright, that heat produced equal to, what is the formula? I square RT. And you have got this time, no? So this is like time, and you have resistance, that is 2 ohm. You want I now. Now how to find I for these kind of circuits? You know already, you have idea about this kind of circuits. All right, now this 3 ohm and 6 ohm, look at them, 3 ohm and 6 ohm, how they are connected. So whatever these 3 ohm and 6 ohm are there, no, 3 ohm and 6 ohm are in parallel, correct? They are in parallel connection, no? So that's why I am going to find only one resistance, that is RP. RP is equal to, you know the formula, no? So what is that? R1 R2 divided by R1 plus R2, directly for 2 resistors, 3 ohm and 6 ohm. Then it becomes 3 into 6 divided by 3 plus 6, that is like 18 divided by 9, and it becomes 9 ones are 9 twos are, and it becomes 2 ohm. Alright, so RP is equal to 2 ohm. So instead of these 2 resistors, 3 ohm and 6 ohm, I can use only one resistance, that is of 2 ohm. Alright, already we had one 2 ohm here. Look at this circuit, already we had one 2 ohm. Now we got one more 2 ohm. So this is like 2 ohm, and this is one more 2 ohm. Now this is connected to battery of 12 volt. Here is the 12 volt, and here is the key, plus or minus, and here it is 12 volt, 2 ohm and 2 ohm. Now how about this 2 ohm and 2 ohm? 2 ohm and 2 ohm are in series. Now they are in series, right? So if they are in series means I am going to get only one resistance, that is equal to 2 plus 2, and that is equal to 4 ohm. Alright, so I am going to place only one resistance, which is like 4 ohm, and now it is connected to battery of how many volts? 12 volt. Now in this, can you find out the current? Definitely we can find out the current. Then current is equal to, what is that? V divided by R. V is like 12 and R is like 4. 4 ones are 4 threes are. So then we get current is equal to 3 ampere. So how much current is flowing here? 3 ampere current is flowing here. If 3 ampere is flowing here, then 3 ampere must be flowing here also, no? Correct, no? So 3 ampere flows here. Now 3 ampere flows here means this resistance, whatever this resistance 2 ohm is there, that will get heated. That will get heated according to the Joule's law of heating, no? That is like I square RT. You have to do it below, but as I have space here, I am doing it. I square means it becomes 3 square. Into R means it becomes 2. Into T means you know already it is 60 seconds. So that is like 60. 3 square is 9. 9 into 2 into 60. Now you can do this calculation. 9 into 60, 9 6 54, right? So 9 6 54, 540 into 2. Then it becomes 1080. So 1080 joule. So 1080 joule is going to be produced if the circuit is on for 1 minute. All right. I think it's quite clear to all of you. All right, dear children. Just look at this calculation one more time. 9 6 54, right? 9 6 54. Then I mean into 2. All right, this calculation is fine. So this is the final answer what we have got. All right, I hope this question is quite clear to you. Now moving on, let's look into the next question, that is like fourth one. What are the applications? What are the applications of heating effect of? What are the applications of heating effect of electric current? All right, so these applications are quite simple, no? So you're going to write the answer like applications of all this. I mean, this answers, no, we are creating as a model for you how you are supposed to write the answers when you have a look at this particular question in the examination. Applications of heating effect of current, electric current. All right, so what is the application? Tell me. I mean, used in iron box, you know this, okay? Heating effect used in iron box. Next, used in geyser, used in geysers, okay? Then used in kettle, electric kettle for making this coffee and all, okay? Hot water you can have bedside. Then it is used in microwave ovens, used in microwave ovens. All right, then used in electric fuse, okay? So electric, this fuse, I mean it is a safety device, no? Electric fuse. The question is following up regarding this electric fuse. So these are the applications. So try to write this electric fuse. Other things are fine anyway. Then moving to fifth question. Now the fifth question comes, what is that? What is electric fuse? What is electric fuse? Electric fuse, what do you mean by electric fuse? Tell me. Electric fuse is it's a safety device. It's a safety device. It's a safety device in any electric circuit. Okay, whatever may be the electric circuit, in that it is a safety device. Now during this short circuit, okay, whenever there is a high current, during high current, during high currents, wire in fuse melts, and disconnects domestic circuit, whatever circuit, disconnects circuit from main supply. So whatever main supply is there, from that it disconnects. All right, so this is the explanation. What is a fuse means? Simply you can say it's a what is a fuse? It's a safety device, electrical safety device. Okay, you can use one more word here. It's an electrical safety device, like that you can say. It's an electrical safety device in any electric circuit. During high current, wire in fuse melts and disconnect circuit from main supply and all. You can explain that in a many parts. It will come. That question will also come. All right. So next is that question only. Sixth question is like this. So what is the sixth question? This is explain the working of an electric fuse. Explain the working of an electric fuse. How it acts as how it acts as safety device. Of course, electric safety device. Okay, we have to explain this. Okay, so working of fuse. So we are going to have a look at working of fuse. We have to look at the domestic circuit also, but in electricity it is not there. In magnetic effects of electric current that comes, but working of this fuse, how it works, no? So every home has some power rating. So power rating of any electric circuit, power rating of any electric circuit is fixed. Okay, so for example, you can take the power rating to be 1 kilowatt. Just an example, 1 kilowatt means 1000 watt. Okay, 1000 watt. All right, now voltage rating is also fixed. Voltage rating is also fixed. I mean, any circuit means its voltage rating is fixed. For example, in India the voltage rating is like 220 volt. So irrespective of whoever you are, your home will be provided with 220 volt. All right, so then definitely you can have one formula, no? So what is that? P is equal to VI. So P is equal to VI means what is P? 1000. What is V? 220 into I. All right, are you understanding this? P is equal to VI. This is very important formula. Based upon this, already we have discussed in the last video. All right, now the power rating is 1000 watt. So that means what will be the current rating? Tell me. Current is equal to 1000 divided by 220, it becomes 00, and 2 11s and it becomes 250s, 11 1s, 11 4s, then 5 is the carry, sorry, 6 is the carry, I guess. 11 4s, 44, and 6 is the carry, 11 5s. So almost we got current as 4.5 ampere. That means this is the current rating. Okay, what is this? This is the current rating, so which is fixed for this circuit. Now if any current more than this comes, means the fuse wire will melt. All right, so if current more than 4.5 ampere comes, then fuse wire gets heated and melts. This way it disconnects. What it disconnects? It disconnects any electric circuit from main supply to keep it safe. All right, it melts. For example, this is a main supply. We have main supply here, and here is the fuse. All right, it will be having one wire like this. Okay, and inside this is our circuit, so domestic circuit and all, and here is the fuse, and here it is a main supply. Now from this main supply, now what is, I mean, this circuit, whatever this circuit is there, so it is going to work on how many amperes? 4.5 ampere. If current is coming more than that, means it will melt. Whatever fuse wire is there, no, it melts and it will be disconnected. All right, and whatever this circuit is there, that is going to be safe. So this is how it works. All right, usually the working of this fuse and all its properties and all, they'll be discussed in magnetic effects of electric current also. There also we are going to study one topic called domestic circuit. So in those domestic circuit and all, we are going to explain this. So till now, up to this, if you write the answer, I think it should be enough and you should be getting full marks. All right, then moving forward, 7th question is like this. On what principle does electric fuse works on? On what principle it works on? Tell me. I mean, it works on the principle of a heating effect of electric current, no? Correct, right? So it works on the current is passed. If more current is coming, means it gets heated. If rated current is coming, means, for example, in the last class we had 4.5 ampere, no? Up to 4.5 ampere, it won't melt, no melting. So it won't melt. All right. So if current is like more than 4.5 ampere, then definitely, I mean, it gets heated and it is going to melt. So if it is melted, means, I mean, the circuit gets disconnected. So it works on the principle of heating effect of heating effect of electric current. All right, so this can be asked for 1 mark. All right, fine then. So this is not necessary, so whatever I have written here, this is not necessary, and just to explain the things I have written that. All right, so moving forward, let us look into this 8th question. So 8th question is like this. They have given one circuit. That circuit is like one resistor and one more resistor here, and they have connected one battery here, and here is the key. Okay, and plus or minus, and it is 10 volt, and it is 3 ohm, and this is how much is this? This is 4 ohm. All right, now the question is, if the key, question is like this, if the key is closed, if the key is closed for 15 seconds, find the amount of heat produced, find the amount of heat produced in 4 ohm. In 4 ohm, how much heat is produced? All right, look at this. For example, here it is 10 volt, no? So here also this is parallel connection, means it will also get how many volts? This will also get 10 volt. All right, and time is given. How much is the time? Time is equal to 15 seconds. Now for heating, no, if you want to know about heating, so heating is equal to one formula is there, I square RT. Not only I square RT, we have one more formula, that is V square by R into T. Actually heating is equal to, the main formula is like power into time, right? So this power can be written as V into I, and this power can be written as I square R, and this power can be written as V square by R also. We have V here already and R also, so again we have to find the current and all. So instead of that, what you can do, you can use one trick, no? So what is that? You can do it as V square by R into T. Correct, no? So V square by R into T means it becomes I square RT only, because look at this. So V square means what it becomes? V means what? IR, right? So it becomes IR whole square, then divided by R. So V square by R is the same as that of IR whole square divided by R only. Correct? Then it becomes I square R square divided by R get cancelled, and it is I square R. Correct, no? Are you understanding my point? So that's why, so instead of this I square RT, you can always use V square by R into T. I hope you are getting my point, as directly we get the answer. Instead of finding this current and all, we can go like this. Now how to do this? V is like 10, then it becomes 10 square, divided by R is 4, and into 15. All right, so it become 10 square is 4, 10 square is 100, 100 divided by 4 into 15, it becomes 4 ones are 425. All right, so 25 into 15, 15 5s are 75, 7 is the carry, 15 2s are 30, 37. So that is like how much heat is produced? 375 joule of heat is produced. Alright dear children, I think all kinds of questions have been covered in these 3 videos. If you still want some other kinds of questions, you can always send me, and you can always comment in the comment section, and definitely I will be making videos on that. And to support all the efforts like this video, and share it with your friends, and definitely comment what are your thoughts, how did you feel about the video, and don't forget to subscribe to the channel. All right, you are going to get the entire content of physics and mathematics on this channel of Kalparaksha classes. All right, thank you very much. Have a good day, and bye bye.